Let's talk about how to solve these by hand. We're going to, first off, we're going to list our steps over here for what we're going to do. Step 1, if you need to do these by hand, the easiest thing to do is to start by bringing everything to one side. So I'm going to start that over here. I'm going to minus 3 to both sides and add x to both sides. So I have 2x squared plus x minus 3 is less than or equal to 0. Now the reason we bring everything to one side, why this is helpful, is because sometimes it's really hard to be able to see where this graph is less than this graph, but it's a lot easier to see when this graph is less than 0. Because we learned in the last video that this less than means below. So less than 0 just means below the x-axis. So what we want to do is we want this graph here, we know it's a parabola, and we want to find where is this parabola going to be below the x-axis. That's what we're trying to find. And that's a lot easier than where is this parabola less than this line. So where is this parabola below the x-axis? So essentially what we want to know is where is this parabola going to be negative. That's what we're trying to find out. We want below the x-axis or negative. So step 1, bring everything to one side, and then step 2, which we already did, we highlighted what we're finding. So I highlighted this, and I specifically wrote out we are finding the negative answers, the below the x-axis numbers. So that's step 2. Step 3 is to factor what we have. This is a quadratic, so we know how to factor that. That's good. If you can't factor it, we always have our backup of the quadratic formula. Now we know this is going to be our harder method of factoring because we have a number in front of the x squared. If there is anything in front of the x squared, that's the harder, longer factoring. If there's nothing in front of the x squared, that's where you can do the shortcut factoring. So the longer factoring, we do the first times the last. 2 times negative 3 is negative 6. And I want to multiply to this number and add to my middle number. So multiply to negative 6, add to positive 1. So I know it's going to be what? Positive 3 and negative 2. That multiplies to negative 6 and adds to 1. So I'm going to exchange that positive x for a positive 3x and a minus 2x. It's the same thing, that's still positive 1x. 3x minus 2x is 1x. I just exchanged it for these numbers I came up with right there. So now I look at the first two. What do they have in common? They have an x in common. Look at the second two. What do they have in common? They have a minus 1 in common. So it looks like my factoring is x minus 1 and 2x plus 3. Beautiful. So step 3, factor, check. Step 4, from the factors, you're going to get your x intercepts. This is something we've learned this chapter. So we take our factors, set them individually equal to 0, and then solve, and those are our x intercepts. So I'm going to have an x-intercept at 1 and an x-intercept at negative 3/2. Step 5 is where we're going to make our sign array. This is the new part of the lesson, so I'm going to go a lot slower here. Now, to make your sign array, we're going to do a couple sub-steps. Step 1 on our sign array. You're going to make a number line that has the x-intercepts and any asymptotes on it. Now, Just so you know, this chapter, chapter 2, you're not going to have any asymptotes. However, the reason I'm making you list both of them is because we're going to start chapter 3 next, and chapter 3 is where we get into asymptotes. And when we do sine arrays in chapter 3, you're going to want the x-intercepts and the asymptotes on our sine array. So for today's lesson, we're only going to have x-intercepts on this number line. Moving forward, we want to make sure to have both. So I'm going to make a number line here, and this number line has my x-intercepts and my asymptotes, even though I don't have any of those. Notice that I put my x-intercepts from least to greatest, just like a number line would be. So there we go. Step 1 of our sine array, we have our number line that has our x-intercepts on it. Next step on our sine array, you're going to list the x-intercepts / the asymptotes on the side. So I'm going to take these x-intercepts, excuse me, and I'm going to list them on the side. Now, we know from our homework, we always write x-intercepts as a coordinate point. Always. So negative 3/2 becomes negative 3/2 comma 0, and 1 comes 1 comma 0. Those are my x-intercepts. Now that I have my x-intercepts listed on the side, the next step is to give each x-intercept its own number line. And this is probably the most confusing part of sine arrays, so we're going to go slow here. Here's what I mean by giving them a number line. We've talked about all chapter. Another word for x-intercepts is zeros. So I'm going to make a number line with this 0, and I'm going to make a number line with this 0. And for each number line, we know the center of a number line is 0. Left of 0 is negative numbers. Right of 0 is positive numbers. So I'm going to take this 0 here, and I'm going to put my 0 over top of the x-intercept for that line. So this one was my negative 3/2 line, so I went above negative 3/2 and it got a 0. And now left of that 0 line are all going to be negatives. Right of that 0 line are all going to be positives. And let's talk about what this is meaning. This is saying if I pick numbers left of negative 3/2, so like negative 2, negative 3, negative 4, negative 5, anything left of negative 3/2, if I plug those numbers into the factor that gave me negative 3/2, so if I plug negative 2, negative 3, negative 4, all those numbers into here, that answer is going to be negative. Versus if I pick answers to the right, or if I pick numbers to the right of negative 3/2, so say negative 1, 0, 1, 2, on and on. If I pick those numbers on the right side and I plug them into here, they're going to be positive answers. So if I take 0 on the right, 2 times 0 plus 3 is positive. So that's why these get positives. If I pick negative 2 to the left, 2 times negative 2 plus 3 is negative 1. That's a negative answer. So that's how this gets its own number line. So now I'm going to come to this one, 1 comma 0, and I'm going to give it its own number line. And the 0 line is going to be above the x-intercept that goes with that line. So I'm going to put a 0 right there. Left of 0 is negative. Right of 0 is positive. So the numbers left of 1, like 0, negative 1, negative 2, you can plug them into this factor and get negative answers. Numbers to the right of 1, you can plug those into here and get positive answers. So this is actually your sine array. Now you may ask, what was the whole point of that? Well, you'll notice in this sine array that I have made columns of sines. That was on purpose. So in this column, I have 2 negatives. We know that 2 negatives make a positive. In this column, I have a positive and a negative. Positive and a negative make a negative. And in this column, I have two positives, and I know two positives make a positive. So here's what we're saying. This section of the graph, left of -3/2, is positive or above the x-axis. This section of the graph between -3/2 and 1 is negative or below the x-axis. And this section of the graph, right of 1, is positive or above the x-axis. So we go back to step 2 where we highlighted what we're finding. We're finding below the x-axis, aka the negatives. So I'm going to take my highlighter again and highlight the section I'm looking at. This is my negative section. This is the part of the graph that is below the x-axis. So my numbers that are my answers here that are below the x-axis go from -3/2 up to 1. And I know I'm going to use brackets on this because of the equal to. So that is my answer. This is the portion of the graph that is going to be below the x-axis. And you could graph this in Desmos and you'll see that these are the x values that are below the x-axis. So instead of having to graph this every time and see where it's above and below the x-axis, instead we can create this awesome sign array that tells us the positive and negative portions of the graph. So that is our first example of a sign array. In the next video, we'll try out another example.